Okay, so the YouTube's just starting up now. And give that just a second to start. Okay, so we got a few attendees already on. There's a few more that'll come in. So if you want to go ahead and get started.
Beautiful.
I can see you now, and then you'll just need to share your screen.
I will. Just let me find the button. Share screen, and it's going to be this screen. Share.
So I can see the Azure portal.
Beautiful. Beautiful. Let's start the presentation then.
Okay. So, yep, we've got some attendees on there. Go ahead and take off.
Beautiful. All right, welcome everyone. Thank you, Bill, so much for organizing this, and thank you people who are on joining us on a Saturday that is a long weekend in Australia. So thank you so much for your time and being here. My name is Imad Alashi. I'm a lead consultant with Telstra Purple. And today we are going to talk about the self-hosted Azure API Management Gateway. But before that, let's have a quick recap on API management itself. I know this might be boring, but it's, please chime in any minute, send a message to Bill on the QA and interfere. I'd like this to be as interactive as possible. So normally when you have, as an organization, you have APIs that you want to expose to the public. You have to think about a lot of things that need to be in place in order to have a healthy web application or web API. Things about security, throttling. You don't want all the clients have the same access to your APIs. You want to do some transformations on the data. You want also to abstract your endpoints because you might host them in different ways, Azure Functions or app services or on-premises. So you want to do a lot of things as part of your web APIs. The normal way is, or not the normal way, like say the way that is maybe think people can do it by hand is to craft these functionalities yourselves, which is not really optimal. This is when, Yasmin, my daughter, oh, Yasmin, Baba, I am in a meeting. Can you come back later? Thank you so much. With all the warnings in the world, beautiful. So yes, so you usually do this by hand, but with API management functionality, these things are done for you. So it's a layer that sits between your APIs, the orange ones in this spot. Oops. And your clients. So Microsoft has a service that's called the Azure API Management that does this for you. It is consisted of 3 components. The developer portal, which is a portal that the developers of the clients, the consumers, can go to this portal and discover your APIs and learn about your APIs. Your APIs will be listed for them. They can look at them, see what the parameters that they take, the responses that they normally respond, and you can test them. This is the first bit of the Azure API Management Gateway. There's also the gateway itself. The gateway itself is the component that really sits between the clients or the consumers and your APIs. This is where the magic happens. This is where the throttling and transformation, this is where everything is happening. The last bit is the management plane. And this word plane is really fancy. It's just a way to express that this is the portal through which you can configure your gateways. You can define your APIs, you can define your policies in that gateway. All of this is done through on the management plane. So all of this is beautiful and very nice. If your API is sitting with the application gateway itself, if you allow me to elaborate, let me just clear this thing. Your APIs, if they are sitting in Azure and the application gateway itself is also in Azure, you probably have no problem. The problem is if your applications are really sitting out of Azure. Things like on-premises or examples of hosting your APIs on another provider. Now we are in an era where we have the tendency to embrace multiple cloud providers. And then if you have your API in that cloud provider and your application API management gateway is sitting in Azure, you have a problem. So for example, this is the picture that you would like. The clients, they have to go through the API management gateway in Azure and then going back to your on-premises API. This also does not make sense if you really want, if your clients and your on-premises APIs are sitting in the same network, or that your APIs are on your on-premises only, or if you have them in the other cloud provider. So what are the drawbacks of having such a setup? First of all is latency. This hoop from the client to the Azure infrastructure and then back to your APIs and back again and again, this is not a non-zero transfer. This is like a physical distance that the bits and bytes has to go through. So this means you have lower latency. The other problem is that if you want to really secure your APIs, or you have a governance on the data that is coming out of your data center, you'll have a problem, because this problem is happening and going out of your data center, and you will have a problem with that. Even if your consumers are within your network, you are going to Azure, and you will probably failing this constraint. The last problem with this setup is that cloud providers charge you for any egress, any data that is leaving the data center, you pay for. So if you are hosting it in another cloud provider, you will pay for the data coming out of the cloud provider, and you will also pay again once you are leaving the data center. So with all these drawbacks, Microsoft introduced the new service that's called self-hosted Azure API Gateway. So a couple of slides ago, we looked at the three components that makes the Azure API management: is the developer portal, the gateway, and the management plane. What Microsoft did beautifully is that they put this gateway component in a Linux container. And if you have been following since the morning, you've heard Bill talking in the keynote about how containers are going to change things, and they are already changing things in a lot of places. But embracing this concept is almost replacing virtual machines, and there's a lot of tendency going towards that. And this is one of the things that we can benefit from containers. This is exactly a beautiful use case for that. So what Microsoft did is that they put this component in a container, and what you can do is that you can deploy this component, the gateway component that does all the magic. You can deploy it in your data center within the cluster on premises. This means that once you configured your application gateway, any traffic that comes from your client does not really need to go all the way to Azure infrastructure. Something happened.
You still there?
My PowerPoint slide stuck. Awesome, Mac OS, awesome. People complaining about Windows, I complain about Mac OS. I have no idea even how I'm gonna change this. All right, is there a task manager in? Oh, beautiful. I can't even switch screens.
Not a Mac person, sorry.
Like, I don't have really alliance with any operating system, but people have been praising macOS way too much, more than it should. I think I have to restart. I'm really sorry for this. So if you allow me to just sync in a couple of minutes to just get this screen off my monitor.
Okay,
I'll be back.
We'll wait for you to come back. Not a problem.
I'll be very fast. Thanks so much. Cheers.
Any questions or comments while he's doing that, or any questions on the sessions later on? What I'm doing, I'm going to create a new YouTube channel that is Global Integration Bootcamp 2020 Melbourne AU, and the live ones will still be out there as the live, but what I'll do is I'm going to do a bit of an edit down on the ones that we've got from the recordings that I took out of Zoom, and then I'll have those up there probably sometime this week, so that if you've got other people in your organizations that would like to view these and things like that, they'll be available out there to do that. So, and this being the first online time we've tried to do a big event like this online, there will be some teething problems, people's machines, things like that. So I think that, and I would be interested too in the feedback from this, is because I know we currently do the Integration Down Under webcasts. We do those once a month. They've been a little bit sporadic lately because of a lot of the other events that are going on, but we will be doing those on a monthly basis. And I'm also looking at doing a similar thing with the global or with Azure DevOps. So if you're interested in DevOps and those type of things, we'll be doing that. I will also be uploading a video to that YouTube channel from Michael Stevenson from the UK. He's done a recording for Global Integration Bootcamp in India on the using Terraform. as with your integration. Looks like Imad is back.
I'm really sorry, folks. I'm really sorry.
There you go. That wasn't that long, so
That's cool.
I will let you have it back.
And I'm sure that you probably have enjoyed the entertainment of Bill much more than me. So,
okay.
All right. So sorry. So we were saying that now that with the Azure API Management Gateway, the component is hosted in a container, and this container is deployed in your cluster, the clients will not have to jump to the Azure infrastructure or the data centers. They can just go directly to your data center and access your APIs through this gateway and consume all the functionalities of the gateway that it provides. So, for example, if you do some transformations on the payload here, the transformation will happen within your data center through the gateway. It will not have to go through the Azure API data center in the data center. This also means that you don't have to pay for any data coming out of Azure. There is very low latency, especially if they are in the same network, and you will also comply with the governance of the data not leaving your data center. The beautiful thing is that the way that Microsoft designed this is that the component in the container communicates to the Azure API management every 10 seconds to pull its configuration from there. The policies that you define, the APIs that you define, it gets all of the information, and also it pings it and says, I'm healthy, I'm healthy, I'm healthy. This way, in the management plane, you can see the gateway listed in the portal, and you can do all the changes that you'd like to do, and the data will be, or the policies and the configurations will be pulled 10 seconds later, or maybe less. This means that the admins on these clusters will be very happy because they don't have to provide any opening for configurations going into the cluster, because it's just a normal outgoing endpoint asking for stuff from the internet, which is beautiful. With that, let's have a demo. Well, because it's all fun in the demos. All right. Currently, I'm in an application, API Management Gateway service in the portal, Azure portal. And we'd like to create a gateway that helps us, that can be deployed in our data center. But before we do that, let me just show you my cluster. So I'm starting now Minikube. I already have a cluster that I have defined before. And this cluster, and this, you can think of this cluster is exactly like a cluster, Kubernetes cluster in your data center. It's very closed environment. It's not exposed to the internet. Only services and pods within the cluster that communicate with each other. So it's a pretty closed environment. There's different flavors deploying the gateway as a container from Microsoft. There's the Docker way. If you don't have a Kubernetes cluster, you just have a Docker on your machine or the virtual machine, and you want to use it directly on the machine. Or if you have a Kubernetes cluster, which is being embraced more and more these days. Microsoft provides two ways to deploy this, since it's a container, and a container lives both in this beautiful way. So in today's example, we will go with the Kubernetes one. Once my cluster starts, because I had to restart my computer, let me first change the or not. We don't have to change anything. Let me get all the components within my cluster. You'll see here that I have a deployment called weather forecast. This is a web API I created on .NET Core that serves mocked weather forecast. We have the deployment itself, and we also have a service. If you are not familiar with Kubernetes, it's a way to expose a web application within the cluster itself, because there's a lot of pods that can be created and terminated. You want to provide something like a load balancer, small load balancer between all these pods. So there's the concept of a service where everyone who wants to access these pods or web application will communicate through the service. Having said that, this service is entirely enclosed in the cluster. No one can access this service from outside the cluster. So if I can give you an example, what I'm going to do is I will go into this pod. So now I am connected into the terminal within a pod in the cluster. Yeah. So this is any command I execute now. That is within the network. It will stay in the network. So, for example, if I invoke curl and I say weather forecast, and the controller that in my API is also called weather forecast. So we say weather forecast. You'll see that a JSON is of a mocked temperatures around the places. If I try to access this endpoint from anywhere else, I will not be able to. Yeah, it's very simple because it's very enclosed. Now, what we can do is we can put an Azure API management gateway in our cluster that can sit between this service and any client or consumer who wants to consume it. So if I go to the portal again, I'm going to go to the APIs, and first of all, I will define the API before we define the gateway. Bill, please, if there's anyone have any questions, I'm very happy to answer them while we are going.
So far, there's no questions.
Beautiful, beautiful. All right, so I'm creating a blank API. I'm gonna go with the full configuration. Sadly, it's not really full configuration. There's another configuration that is hidden that we're gonna chime in a minute. So the display name, let's call it the weather forecast. The name, let's keep it as is. The web service URL, this is the backend service that we're gonna hit. In our case, it's just the weather forecast service. You can see that there's no fully qualified name or whatever, because this endpoint is really within our cluster. It's not on the internet. It's not HTTPS, so I want to remove this. And I also want to add a suffix, because if our API management covers a lot of APIs and a lot of products, you'd want to add a suffix to distinguish this from the others. So I'm going to call it my weather. Right, create this one. Before we continue, I also want to remove the subscription required for this one, because if I keep this tick box, this means that anyone who makes a request to my endpoint, in order to get a successful response, they have to be part, or they have to supply a subscription key from the subscriptions below here on my left. So I don't want to do this. I want to make the example as simple as possible. So while it's creating, hopefully it does not take long. Beautiful. Now, if I want to go to design and add an operation. I want to add a default endpoint. This is the default endpoint that we're going to hit. I don't want to provide any concrete trailer of the URL. I want to be the default one, and I want it to pass through whatever trailing in the URL to the backend service as is. So this is the front end. And you can see in the backend it's just the weather forecast, our weather forecast. Now that we have defined our API, of course, if you go to the settings part, and this will not work, of course, because there's no backend that is accessible from Azure. This is an endpoint that is sitting in our data center or Minikube. Now let's define a gateway. This is the new bit that is really interesting. So we want to create the gateway component. I'm going to call it the weather forecast gateway. The region here, you just specify, it's an arbitrary string. So we're going to say Australia East, and then I will pick the weather forecast I have just created a minute ago. Add now this gateway only provides access to the weather forecast. Allow me to have a sip of water. Now, if we open this further, first of all, before opening it further, you can see that there's the status, there's 0 nodes. And the reason is because we haven't deployed this component yet. We are going to open it, go to the deployment, and you'll see here that there's 2 different options between deploying it through a Docker command or Kubernetes. We're going to pick Kubernetes. Let's copy all of this YAML and open it in Visual Studio Code so I can explain to you what's going on. All right, maybe zoom a little bit. The first part of this YAML, you might not be too familiar with Kubernetes, but that's all right. It's just the concepts are really the same everywhere. First of all, we define a secret resource in our cluster. This just holds the key through which the gateway component in our cluster will talk to the API management portal to pull the configuration from. Don't worry, I'm going to delete this API management after the presentation, so this will not exist anymore. Don't print screen. And then we have the config map. This is a configuration to just say, to tell the application gateway which URL it has to use, the endpoint service for the management. And then we have the deployment itself. This is the container. You can see that this is the container, and you can see that it's pulling the image from the container repository from Microsoft. And internally, this container exposes the the ports 8080 and 8081 for HTTPS. The last bit of the definition is that we also want to create a service, which is like a small load balancer within our cluster, so that people can use it to go through to the gateway, because the gateway is a pod, it's a container. So we need to provide this service. In this one, you can see that it's a node port deployment service. This means that I can access this service only from my machine through the IP address of the local cluster. So let's save this file, save as. And let's go to source playground, our guy here, and call it weather forecast.yaml. Now, if I go to my command, let me exit from here. Now we don't need to stay in the terminal. I'm going to clear this thing. Let's see what files we have. We have the weather forecast. So if I say Kubernetes apply, which means deploy all the configurations and the deployments in the YAML file, and I'll choose weather forecast. Now we have a gateway deployed within our cluster. So if I say get all, like Kubernetes kubectl, get me all the resources in the cluster, you'll see a couple of new things that we didn't have before. First of all, you'll see a deployment for the weather forecast gateway. You'll also find a corresponding service. This is the corresponding service, and the pods that are really having the containers running behind the scenes. This means that I can access, if I want to access the weather forecast deployment, I can go through the gateway and get all the functionalities within. So if I, let's say, Minikube service list. So these are the services that Minikube has, the cluster. You can see that we have this weather forecast gateway. I can access it through my the IP address of my local cluster. And this is only for demonstration. Like we don't really need to expose it outside of the cluster, but I can use some of the tools to demonstrate this to you. I think this is the one that is not HTTPS, so I can copy that. I'll open Insomnia, which is a fancy Postman. If you are familiar with Postman, I think you have seen it in the previous presentation. It's just a tool to make requests. So I'm going to put the IP address with the port, and you can see that I'm using the gateway suffix that we have defined in the application gateway in the portal, and then the weather forecast controller itself. If I hit send, voila, we get the results. Remember that this is the application gateway sitting in the cluster, and all the requests are going through that application gateway to serve my weather forecast that is sitting within my cluster. It's not exposed to the public internet, nothing. Now, this demo will be very boring if we kept it to this point. Let's do something interesting. Let's go to the portal, and in the API, let's go to the API and add a policy. First of all, before we go there, let me just show you the status. Now you can see that we have a heartbeat and we have a status for the gateway, because the gateway is continuously pulling the management plane. If we go to the APIs and we go to the weather forecast, let's say I want to do some transformations. I want to move it from JSON to XML. So in the outbound policy, we can say, maybe it's better to put it behind or after the base. Transform, was it transform? Or is it JSON? JSON to XML. JSON to XML, I want to apply this always. I don't want to consider the header, and this and parse date, we're going to keep it as is. Let's move this extra angle bracket and save. Now, if we wait a little bit, what happens is that the gateway in my cluster will ping the control plane and get the configurations, including that one, and apply it within our cluster. So if I go back here and invoke this endpoint, if everything works fine, we will see that it's XML, which is beautiful magic. Imagine this, all this beautiful functionality of the application gateway is sitting within your cluster, and you don't have to go through to the public internet to get this functionality. This is really, really, really neat. I think this example shows you the bulk of what I wanted to show you today. Let's head back to the presentation and see what is the drawbacks, because there's no awesome solution for everything. What are the drawbacks of this thing? The first of all, you can see that there's a fair bit of ownership. I have to grab this gateway component in a container, and if I manage the Kubernetes cluster, I have to put it there, deploy it, make sure that it's running fine, scale it if necessary. All of these things are things that I have to do myself, compared to not doing any of this if I keep it in Azure. Another problem is that even though that the component is exactly the same as the, like it's not a replica of the component that is being deployed in Azure data centers, it is exactly the same thing. But there's several things that are not happening. First of all, it's the features are being added as we go. So for example, log to event hub policy is not there yet. The service fabric integration is not there yet. Downstream HTTP2 is not there yet. But also things like caching probably is not going to be there at all. There's at least my understanding, there's no plans from Microsoft to enable this, because it's to enable this feature, you need a component beyond what the gateway container does, because the container it's very, very compute based container. It does not really like if you want to provide cache, you want a mechanism to store the data in somewhere, and this is going to bring a lot of complexity. So this is what we are going to get with the self-hosted gateway. The things that also we have to keep in mind is that once you deploy it to your data center or your other cloud provider, you have to make sure that this container can access the internet to put the configuration from the management plane. If for some reason there was a disconnection and the gateway cannot put the configuration from the application gateway control plane or management plane, your gateway will still work because it has pulled the configurations and it's hosted in memory while it's serving. The problem with that is that if your gateway in the cluster dies for some reason and it's spawned again, it will not work. So it's just an in-memory configuration. It's going to be holding the configuration in memory. These things to keep in mind. There's a broad future for this. Like I can see that this people will start looking at this in more details, especially with the insight that Bill mentioned at the beginning in the keynote. And by that, I have no further things to say. So I will finish early, even though that we have been disconnected, and open the floor for questions if you have anything.
One question from me. Thank you very much for that. That was really good because I haven't had a chance to play with that. Is that what version, what tiers of API management will let you create the gateway?
Yes, good question. Currently, because it's preview, it's only in the developer one. Having said that, there might be self-hosted gateway. It's also in the premium. but there is number 5 note. Let's see what 5's. Unlimited gateway deployments and replicas. No additional cost while in preview. General availability pricing will be announced separately. So it's in the developer and in the premium.
Yeah, I was afraid they were going to do that because it makes it fairly expensive when it's only in premium.
Yeah, I can imagine. I think it's the more features, the more expensive things become. I think also another thing is that my understanding is that if you have a data center and if you have a cluster that you are already managing, and you most likely you are an organization that will go with a premium subscription anyway, a premium tier. Startups or small companies most likely they don't have such complexity and they don't have these closed data centers, so probably they will not need such a functionality.
Yeah, but I'm running into the similar issue with the VNet support, and it's actually the smaller companies that don't understand the security that well.
All right.
That want to put everything in a VNet. So it does take a little bit of education around that to do some of those things. So yeah, it's going to be interesting.
Yeah.
Have you used Front Door in front of API management?
I haven't really. I'm really sorry.
No, I mean, it's something that everybody probably should look at. I meant to mention it in the keynote, is that Front Door is a new product that kind of replaces the traffic manager and also the web application firewall.
Yeah. Sure. And it's also globally available. It's multi-region, so it's a crazy, actually. It's really good.
And the interesting thing is it's a new product on the scene for Azure. But from what I understand, it's been running Xbox for a long time. Xbox Live.
I see. Well, Microsoft has this tendency, doesn't it? Like Service Fabric. Fabric has been running Azure since the beginning, but only released years after as a public service, which is awesome. So like it's a proof that these services and products really work.
Yep. So is there any questions at the moment? So if not, we'll go ahead and close this one down, and then we've got about 15 minutes until the next session starts.
Yeah, really. Thank you, Bill, for organizing this, and thank you everyone for tuning in. And sorry for all the heckling of my daughter coming in and my disconnection and me going fast, afraid that I might have missed something. So thank you for your patience, and hope to catch you on Twitter. Thanks, Bill.
Thank you.